Kinetic theory is actually quite amazing. It's the tussle between energy and force. This constant battle which keeps things in certain states of matter, these three states of matter that you'll be used to, and these three particle pictures that you'll probably be used to drawing or seeing and discussing, but you need to make sure you get it right to the exam board specification level. And what we're talking about is the kinetic theory of matter. So we've been given this solid carbon dioxide, and it's a good example of where we can talk about kinetic theory, the particle theory of matter. So this is solid carbon dioxide, or sometimes called dry ice, and they've just given it to keep our cannolis cool, but we didn't give it time, so we just ate the cannolis straight away, because they're amazing. It's a good example of what you need to know about kinetic theory. Now, kinetic theory is what you probably have referred to as the particle theory of matter. It talks about the kinetic energy of the particles in matter and the forces that attract them together. So essentially, all things are made of particles which have more or less energy and higher or lower forces attracting them together. So in a solid, like this solid carbon dioxide, then it has low energy and high force. So we say they're in a fixed position, vibrating on a spot. And it's really important that when you say things, okay, if we start to heat these up, as these are being heated by the surroundings, you don't say they start to vibrate. They are already vibrating, but just on the spot. So you want to say that they vibrate more, or they move faster or with higher energy. Dry ice is something that's sublime, so it goes straight from a solid into a gas, so you can see that happening just here. And in the gas, that's the highest kind of energy state and the lowest force. So they move further apart, they're no longer in that fixed position, and they have very high energy, so they're moving randomly in all directions at very high speeds. It's also really, really cold, and they've given it to us to keep the cannolis obviously cold for longer. You can see the water vapour in there is actually freezing on the dry ice, it's that cold. And actually, if I was to hold it for very long, I'd probably get a little burn, a little cold burn, as the energy leaves my skin really quickly. I dolce di donna Vincenza. So you should always be mindful to talk about the energy of the particles and the forces between them. Don't be talking about their arrangement in neat rows and columns like a lot of people do. Just talk about how much energy they've got and how much force they've got together. That's kinetic theory. So if you learn it like that, you're always going to remember to talk about the energy of the particles versus the forces that are binding them together. These, what we call weak intermolecular forces or electrostatic forces between those particles. The other thing I really like about dry ice is you can see, you can pour it. So you can see the carbon dioxide gas, which is just literally being poured off the edge of this tray. And that's because carbon dioxide is more dense than the air around it. It's more dense than nitrogen. So it actually sinks in the nitrogen. Pretty cool, huh?